So this is a walkthrough of the Noble Ape Simulation recorded July 23rd, 2012. It's important to give the date because the simulation is relatively dynamic. I would estimate typically within any given month about 10% of the simulation source code changes, and sometimes that results in structural changes, so it's rather difficult to give a presentation of this nature because the source code will change. So almost by necessity this will be out of date almost as soon as it's recorded. But I just wanted to give a general overview to describe some of my, I guess, engineering thinking associated with the simulation, with the view that folks who see this video should get a sense that these engineering models are used. So the simulation is made up of multiple directories, and each of these directories relate to a certain component of the simulation. So to start off with, there's the Nobel Directory, and the Nobel Directory contains all the underlying elements of the simulation. These are pre- or underlying not simulation elements. They're the kind of atomic components, basically, that make up the simulation but are not the simulation. So in each of these directories, I'll start with the general format. There is a header file which is the name of the directory, and this contains the interface outside each of these directory groups. So for example, the Nobel directory, the Universe directory. Now with Mac it's not quite that way, but the actual particular platforms are esoteric. Similarly, GUI, there's a shared interface which I'll move over to GUI, but that at least has a GUI header. And Entity, which is a new directory but was created because there were so many aspects associated with the Noble Ape itself that a new directory was created. So if we start with the Nobel directory, which is the lowest level directory within the header file, you see a wide variety of different things. So these things relate to file handling, for example, also things associated with the version name, the date, subversion version, version number, copyright date, all these kind of things. Signature, Noble Warfare is included here as well. The Noble Directory is used by multiple potential things, not just the Noble Ape Simulation, but it's shown here for Noble Ape Simulation. It also contains ApeScript, and ApeScript can be removed from the Noble Ape Simulation, so the ApeScript componentry is here as well. And recently the land, the thing that actually creates the landscape environment and also the weather, was moved into the Noble Directory because it didn't really fit inside the Universe Directory anymore, and there were other things that were going to start using the landscape and weather simulation. So it was easier to migrate that through the Noble Toolkit, and sufficiently, well, thankfully the land is sufficiently low level that kind of, yeah, it's not an ideal fit. But it's contained within the Noble Directory. So one of the questions that I did receive was where this thing is executed from. In the case of the Mac version, it comes through the main execution, and here it's checking to see the C value, which means that it's run from the command line, and it'll send that accordingly, and then it goes through this. And each of these represents one of the windows. There are two windows for the Mac. And these are the related things associated with mouse interaction. So from the top down, you go from the platform-specific code, and this would be GTK for Linux or Win for Windows, that goes into the GUI, that then goes into, I guess, the universe, that then has the entity code from that, and then the Noble Directory. So that's from the top down in terms of interfaces. And each of these, so from Mac, unfortunately Mac, it's counter-rule because of the Mac naming conventions, but through Noble Mac View, through what is used here, which is the shared header. And the idea is basically to rewrite the GUI progressively, but it'll need to be done OS by OS, and the Mac one was the first one that used this shared interface because basically there's only a very small number of things that the GUI does, and rather than having the somewhat convoluted control, I rewrote it in terms of using shared interface. This still needs to be moved to Linux and Windows, but anyway, it will be done eventually. So this is the shared interface, which is basically the rewrite of control to get down into it. So just taking some ideas here, the initialization creates all the initial settings. This is the window identification, so based on the height that the window is passed in, it's given a window identification which will either be graph view or, graph isn't really used anymore, but anyway, it's still in here, which will either be the map view or the terrain view, basically. And because these are run in separate windows, you need to specify one if you only want something done once. So here you want the initialization of control of the kind startup. There are many different kinds here. I think there are 4 in this case. So you have startup, memory setup, which kind of clears the memory, new simulation, which means that you've just hit a new simulation, but obviously you don't want to clear the memory or anything like that, you just want the new simulation run, or loading file. So the same interfaces are used for multiple purposes. So if we look at, again, control init, so what control init does is it clears all the errors. There's a speed undraw thing you don't need to know too much about. What I will say through this is there are some things you don't need to know about. If your interest is purely associated with stuff that's going on, for example, with the entity, you'll only need to know what's going on in this directory, with the view that if you understand the interfaces in this directory, you'll be able to either move up or down accordingly. But anyway, this view also has brain hash code, which is no longer used, and if the threading was turned on, and with this version I'm not sure, no, threading is not turned on, so that's not run. So this is interesting. What this is initializes the sim and assigns the output to be drawn off screen. So it just basically passes the pointer through so the draw off screen can see it, so all the drawing can go through. This literally puts out some memory which is then utilized by the off-screen drawing. So if we go one down again, and what typically happens at each of these, with each of these directories, is that there'll be a main, a main point, and then there'll be offshoots. So in the case of GUI, it's control as the main point, and it has, well, it's interesting now. I guess shared is, but control has historically shared as moving in that direction. In the case of the universe directory, it's sim, and from that has the file handling, the console handling. In the case of the entity directory, it's being. But each of the directories has a main interface and then the kind of offshoots. In the case of the Noble Directory, it's slightly more interesting. It's probably really I/O, although each of these things has different purposes. So if we look at sim init, it puts through the kind of simulation run it was from the previous, as you may recall, whether it's a file, a new simulation, whether it's clearing the landscape, or whether it's the initial run which will allocate memory. We'll get to that. A randomizing factor, the off-screen size, which allows for basically a certain amount of memory to be allocated for off-screen size, and the size of the land, because basically the thing that initializes the land requires there to be an additional buffer of information that's passed in, which is typically used from some of the screen memory that isn't needed immediately. So these two values are for the 8 brain cycles per second. Real time and last time is for tracking time, basically, because the randomizing value passes the time through. If there are special external birth and death functions that need to be called, these are initially zeroed. Similarly, if there's a fixed random number which is used for running the simulation over multiple times, that's provided. And okay, now we get into the meat of the. So if it's of kind startup or memory setup, then sim memory is run with the off-screen size passed in. Sim memory sets up the memory initially with a very large allocation of memory, so it's a solid block of memory that the Noble Ape Simulation works within. Typically, the only exceptions to this is files, and files covers files that are stored in memory, not just files stored on disk. So it initializes the large block of memory, the current location of the memory, which means it allocates the off-screen size first, so that's the first block of memory that's passed through off buffer. You'll recall that siminit is called by draw off screen, or sorry, draw screen calls siminit internally within control init, and that's basically the stuff that's being passed out first, is the off-screen buffer. The land, similarly, is all this stuff is allocated initially, and the map of the land, which is a block of memory as well, size map area. So you've got current location that's just kind of checking through the memory as it's allocated. Similarly, in the case of like the GUI version with a large map, there's a high-res map that's also generated, and this similarly is allocated. There's both a high-res color map and also a high-res height map that's generated, and this is what the two-part means, because they're intertwined, which is to do with how the stuff is represented. And similarly, this is a tied measure, because basically the height map and color map changes through the tidal region, which gives the effect of the water rising and lowering. This could be rewritten, obviously, with the OpenGL version, so you could actually turn on small land for OpenGL and just allow the OpenGL stuff to use the regular information. You then have the weather, which is allocated. The weather contains pressure information over the size, but it's like double. The land size is double the size of the weather, so 2 by 2 different, which means the weather is run in a quarter of the size of the simulation. And then you get the simulation needs to know how many apes it can generate. So if this is preset, then it allocates that. But if it's not preset based on whether the brain is used or not used, this is the cognitive simulation, then the memory allocated is divided by this, which will give a rough indication of the maximum size. And I thought my recollection was a fraction of that was provided. Oh, well, it needs to allocate them anyway. So this is the total maximum number of apes, and then this is provided accordingly. And so the brain locations are, the brain is a solid block of memory. All the brains are in a single solid block of memory, and this is just basically allocating where the brains start through brain base, and this reconstructs where the brains are taken from that block of memory. This all is erased, and that means that originally the idea was that the brains would be compressible in some way, but if they were provided in block, so much the better. Passes on the location, and this is actually where, no, so what you have here is all these bits here, and then it just goes through and makes sure that the allocations are correct for the various things that it's linking in, social linking, episodic memory, all this kind of stuff. I've got wraparound on the text here. And then it makes sure that the brain memory location is correct, and also that the indicators are correctly connected. The indicators are kind of curious because they're not really used in the GUI version. They more come from Bob Mottram's code associated with tracking long-term indicators of the simulation, but they're included in here for historical reasons. So that's sim memory. You then get through that if it's not loading from a file, or if it's not memory setup, then there needs to be some random number generator that creates the genetics, that creates the landscape. So I'm just going to go through these. I don't know what level of detail is really needed here. I can talk about more of these in greater detail, but this obviously clears the landscape size, then this initializes the land size, and this populates the tied blocks, which are the high resolution tied blocks here. And then if you're not loading from a file, then it initializes all the apes and the weather. If you are loading from a file, it doesn't need to do this. The weather's an interesting one because the weather should be loaded from a file and initialized accordingly, but it just isn't in this particular version. Then if threading is turned on, then threading should be pointed on. If, as you can see through this allocation, if threading was turned on initially and a thread came through here that was doing some run of the simulation and stuff and have memory allocated, all this kind of stuff, things would fall over pretty quickly. So this is basically just a protection to make sure that the threading is turned on after all this stuff is initialized. And finally, this selects the Noble Ape to be the initial Noble Ape, and as noted, it returns the buffer accordingly. So each of these things also, I should have explained this initially. You will have an init, a close, and a cycle typically in all these levels. So here, yeah, sim cycle, sim init, and sim close. Close, I guess, could have been called exit on some fundamental level. But this also has the interpreter. So this is level by level, particularly, I guess, looking at the sim level initially, or the universe level that provides into sim. So some other things to say about this universe level. So the file, normally it should all contain, but unfortunately it doesn't. The interpreter code is still outside the file handling, but this handles all the file aspects. So debug CSV, comma separated variables, I think is the term, CSV. So that just puts out CSV information. This puts out landscape information. All the file handling comes through the io.c, and it's a particular file format which io.c goes through and fills out per the, I don't know, Noble Ape file format and what have you. Similarly, being, so all these things are just filling out the file information, basically. And so it goes on. What can I say? Console handles all the console. So there are two levels of console. The first level of console comes through console, and there are a wide variety of functions that you can see through the console version of the simulation. The naming format is typically console means this is something that's actually run, like metabolism, these kind of things, and everything else that's named here, like watch and what have you, relates to actually watching those values over long-term runs, for example. So you have console epic, top, script, open, save, reset, run, step. All these things relate to actual commands that run genome, statistics, probe, what have you. So if there's console in the front, that represents that. If there's watch or something else there, then it's something else, basically, that typically either is being run when the apes are being watched, or these kind of things, basically. Wide variety of possibilities through that. But this really almost could be broken up into two files, watch and console, accordingly, and these related files could come from there. But that's the way this is set up. So if you want to go one level higher, you have GUI directory, and GUI is really through control, which was the original interface, which has now been slowly mapped over to shared, although shared isn't particularly heavily used, so control still provides, and it's not that big, actually. So you have the stuff at the top that relates to basically just handling the Mac console version first, the command line version. But the rest of the stuff, like things like cursor handling, mouse handling, keyboard handling, these are interesting because they have a slightly different interface, I think. So, Control-Sim key versus Control key basically allows for the sim to be passed in, and here it's specifically called directly. So basically the same function, except one you pass the sim in, and the other you get the sim from SimSim, which just provides the sim pointer back. It's a problematic interface, but it works here. Unfortunately, it probably needs to be rewritten to a slightly later. Draw basically does all the drawing in the GUI version, and so similar kind of format. I don't think there's a draw in it, and I don't think there's a draw close, because basically draw comes through really the information which is being passed in from sim init, and that will provide the information there. So all the initialization and closure is done outside of draw. Draw just handles the I don't know, the representation basically through the stuff that's been the off-screen buffer that's been provided through sim init. So they're all, in terms of parts, you still have a draw cycle. However, it draws the terrain, meters, the areas, the brain. There are two entry points through this. I think it's either 0, 1, 2. I think that's how it goes. But in the case of the 0 case, that draws the terrain, the meters, the areas, and the brain, so that is very much the terrain window. And in the case of the 1, that draws the apes and the map, and in the case of 2, that draws all of that plus the weather as well. Let's look at draw apes specifically to see what the distinction is here. Oh, okay, this is the difference between drawing low-res and high-res. So on the map window, the apes are low-res because you're drawing square, visible apes that are on the map. And in the terrain case, you're drawing different apes. You're actually drawing high-res apes on the high-res graphics, which are then mapped over the landscape information. We'll get there eventually, but just going through. So errors just draws errors to the screen, basically, if there is to the screen to be drawn. Each new cycle represents a new screen frame, so the errors have to be drawn accordingly. Draw apes, I've already talked about, associated with the low-res, high-res version of draw apes. Draw tides goes through and changes the tide information, which is done on a colour map, which then is finally rendered. And draw tides here, this is the low-res version for the regular map. Draw error actually puts the string text up on the screen and just goes through. This, I believe, yeah, this is the brain drawing, which creates the rotating cognitive simulation component. Draw weather draws the weather map, which is done through single pixels or combination kind of 2 pixels in the case of rain, so 1 pixel in the case of clouds, 2 pixels in the case of rain. This draws the apes location in high res. For the terrain view, this draws the apes location in low res. For the map view, I'm not sure why that's there, so let's turn that off. And where were we? This draws what's called, I think, meters, but it's basically all the additional information that you see on the terrain view that represents the genetics, the sex, the speed, the direction facing, and the time. So from there, where are we? Draw meters. So draw terrain, draw terrain is actually the thing that draws the landscape out, and this was very heavily optimized. It's not intended that you really understand how this works, aside from the fact that it does. And I still put in little notes associated with optimization, basically associated with how one can kind of go on to optimize it. Like, I think increasingly these times are relatively unimportant. There's been a bit of work done in optimization associated with this. Draw color time provides a color map back associated with the time. So in the Mac version, I think the Mac version only, although it's relatively easy to do through Windows and Linux, I probably need to do it through the Windows version. In the near future, what it does is provides the color basically based on the time of day. And this version creates that's the raw fit to do by linear interpolation. There was a graph view which was used for drawing the Noble Ape body, and here's the kind of fur colour that was put through, and this is the land colour, which is put through. This is the value, and these are the RGB values, and basically it does a bilinear interpolation in order to get all the values between 0 and 255 with a relating kind of RGB spline linking through that. So that's how draw works for that. Where are we? Draw fit. Draw the genetic patch is associated with drawing the fur. It's not really heavily used, but this is actually used through, I think, math patch, which draws both the genetic elements of the fur, but also the landscape. Draw string, relatively self-explanatory. It draws the text basically in the environment. This provides the about and copyright notice. The environment when you get about. Draw pointer returns the specific place in the off-screen memory buffer associated with the graphics window, the terrain window, or the view window. And here are a couple of pixel functions that are used for drawing the overlay, which is the yellow color, or drawing an 8-bit color. In addition, there is a notion of undraw, and rather than clearing and redrawing, there is something which actually records where certain things have been drawn on the landscape and goes back and undraws them, literally goes back and removes them by every point that's drawn is then removed from the high resolution map in particular, because it's actually far faster to undraw something than it is to redraw the high resolution stuff. So currently it's a little bit hand rolled, but typically you'll never have more than 4,000 points that are drawn, and this just goes back and makes sure that those points are undrawn too. And that's draw. There's a lot of additional stuff. So these represent buffers for the icons, which show the sunset, cloudy day, rainy night, this kind of stuff. And also this provides the segment information for the 14 segment displays that represent the characters in the strings that you see on the screen, although increasingly it's interesting when you have a kind of command line version. Maybe some of that information could be put out, and in the case of errors actually I do now put it out through the command line version. So that's the draw. Now, it gets really quite complicated in being, body, brain, drives, these kind of things. So I'm going to hold off that, mainly because this file is getting rather large, and just put this stuff online. And if you have any questions associated with this, tom@nobleape.com. I know I've gone through it relatively quickly, but I just wanted to cover as much ground as possible. Anyway, this is Tom Bartley, currently in Michigan, of all places, signing out.